Hello everyone, I hope everyone is being safe. Welcome back to the course Research Methodology. Today we'll be doing the third module. I am Divyansha Kumar and I am your course faculty for this course. So in this session, we'll be majorly focusing on what is sampling, what is the importance of sampling, what are the different types of samplings, and how do you differentiate between each technique or method of sampling. Okay, so let's start with what is sampling. Sampling, the term can be defined as a selection or a part or a subgroup of an entity or a population. So, for example, you need to collect some data and you know what the population is. But since the population is too large for you to collect data, what do? You take a part of that population and you collect the data from that part of the population. Now that part of the subgroup is called as a sample. And the process of taking that part is called sampling. You need to take into mind two things, that a sample must always represent the entire population and a sample must always be reliable. How do you say that the sample is reliable? We'll be talking more about it in the next few slides. First, let me tell you, there are different types of sampling methods. Two major types of sampling method we'll be talking about. One is the probability sampling method, or also known as the random sampling method. And the second is the non-probability sampling method. All right, next move on to the next slide where we'll be talking more about sampling design. So sampling design, it provides you the basic plan for selecting a sample, or it gives you the blueprint of how do you go about selecting which sample is appropriate for you, what can represent your population. And there are few steps that you need to take into mind when you are selecting your sample. That is, first you define your sampling frame. Now, sampling frame is actually the representation of your population. Let's say that your population is of all those people who are tax defaulters in IT sector. So you will have a list of all those people from the tax department, those who are tax defaulters in the IT sector. Now that list is called your sampling frame. But in your sampling frame, you cannot go to each person and judge their behavior. So what do? From your sampling frame, you select a number, and that is exactly what your sample size will be. Your sample size will be determined. There are different methods in which you can determine your sample size. There are empirical methods. There are scientifically proven methods like the number of variables into 10. The number of variables is actually what you've taken into consideration. So that can be an appropriate sample size. There are different formulas in which you can calculate the sample size. So the next step is you calculate the sample size from your sampling frame. Once you've calculated that sample size, let's say it comes to 10 variables into 10. So 100 is your sample size. So you have a list of maybe 2000 tax defaulters, and from those 2000, you have to select 100 tax defaulters. Now, how do you select those 100? That is called as a sampling technique or a sampling method. And we'll be elaborating more on that in the next slide. Let's start with probability sampling method. So one part is probability, second part is non-probability. There are four ways in which you can do probability sampling method. What do you mean by probability sampling method? It is basically randomly selecting numbers or samples from a finite population. So all the tax defaulters that were there, you have a list of 2000 people. So it is a finite list of your population that you have. From that, you have to randomly select 100 people. How do you do that? You can generate random numbers in MX Excel. You can randomly write 100 numbers or select chits from 2000 numbers. And whatever 100 numbers come, that is your random selection. So this method is called as simple random sampling. It's similar to what you've studied in your school as well, in probability, when you select a few balls from a pot. So you randomly choose those balls. So this is exactly what is random sampling, simple random sampling. You can do it with replacement, you can do it without replacement. With replacement is supposing you have to select a sample of 100 people from that 2000 list. So with replacement is, once you've chosen those, you can re-choose them by putting those 100 numbers back into 2000. So that is with replacement. They have an equal opportunity of being chosen again. Without replacement is, once you've chosen a sample of 100 and you need to select another sample of 100 people, you will not put those 100 numbers back into the pot. So those 100 numbers will be out, and the remaining 1900 people will now be left in your population. So from those 1900, you will now do simple random sampling without replacement. So this is simply one of the methods of selecting your sample. We move on to the next method of probability sampling, that is called as stratified random sampling. Now, by definition, what you do in this is you divide your population in different subgroups, also called as stratums. You need to keep in mind that these subgroups will be homogeneous internally, which means in one subgroup, all the population that you've chosen will have similar characteristics, but externally they'll be heterogeneous. So strata 1 will be externally having different characteristics from strata 2. So let's say in this example, we have divided each strata according to age groups. Now, one strata is having all those people who belong to the age group of 20 years and below. Then the next strata is having all those people belonging to age group of 21 to 40 years, 41 to 60 years, and the last strata is 61 years and above. So internally in strata 1, all those people who are lying in the age group of 20 years and below are there. So they are all similar in that way. Similarly, in the second strata, all those people belonging to the age group of 21 years to 40 are lying. But 20 years and below is different from 21 years to 40 years. So they are externally heterogeneous. So this is how you divide each stratum. And in this way, once you've divided each stratum, you will select sample from each stratum. So from 20 years and below, you will have to, let's say, select 100 people from that. From the next stratum, you will have to select 100 people from S2, 100 people from S3, 100 people from S4. So in this way, you will have 4 different subparts of your sample, and the total sample will be comprising of S1 plus S2 plus S3 plus S4. And this is what is called stratified random sampling. Keep in mind that each sample that you're choosing from each stratum will be randomly chosen. It will not be according to your convenience, but randomly generated numbers that I had already spoken about. They are randomly chosen. So this is how we do stratified random sampling. Now let's move on to the next sampling method, which is your cluster sampling, also known as area sampling. Cluster sampling, similar to stratified sampling, here we divide each subgroup. The population is again divided into subgroups, but in this they are called clusters. So cluster sampling is probability sampling technique where we divide the population into different groups or clusters. We select the groups randomly with simple random, systematic random sampling technique, and the data is collected. Now, in this group, you need to keep in mind, it's just the opposite of stratified. Here, externally, they are same, but internally, the samples are having different characteristics. So let's take an example. Let's say we're supposed to see all those people living in Delhi who are the tax defaulters. So what we do, since Delhi is a big geographic area, we divide it into 4 zones: north, south, east and west. Now these 4 zones are called our 4 clusters. So since the population is belonging to Delhi, So they have the same characteristics of belonging to the same geographic area. So externally, cluster 1 is belonging to Delhi, cluster 2 is belonging to Delhi, 3 and 4. All 4 are belonging to Delhi, so externally they are same, homogeneous. But internally, each cluster will have different characteristics. So suppose each cluster can be further subdivided into, let's say, age group, education background, marital status. So all these are different subgroups or subclusters in which you can further divide each cluster. Now, once you've chosen a sample from each cluster, you will again find out the total sample size, and that will be your cluster sampling. In cluster sampling, keep in mind, you can do different levels of sampling as well. So single stage cluster sampling is where you divide it into 4 clusters and you randomly select S1, S2, S3, S4. Now in S1, S2, S3, S4, you can also select S1A, S1B. So one can be chosen on the basis of age group, one can be chosen on the basis of marital status. So if you choose 2-stage of clustering, this is called as 2-stage cluster. In the same way, we can choose multiple stage cluster sampling. This gets a little complicated. Let's just stick to single stage cluster sampling at this phase in your research. Now let's move on to the 4th type of probability sampling method. That is called the systematic random sampling. In systematic random sampling, what do? It's basically a type of probability sampling method again, where a larger population is selected and randomly we keep a fixed point or a periodic interval in which we have to choose. So in random sampling, simple random sampling, what we were doing, we were just randomly generating numbers and selecting the sample. In systematic, as the name suggests, we systematically generate the numbers. So if I say I need 100 samples, what will I do? I will not generate 100 numbers. I will say, okay, I will select every 5th person or every 5th house in which I need to go and survey. Alright, and every 5th house will be my sample. So similarly, like the example that we've taken here is, let's say we have to suppose survey every 300 houses. My sample size has come up to 300. We have to survey 300 houses. What do? We have taken the periodic interval of 5. Now my first sample number will, first number in the sample will be 5. Then it will be 10, 15 and so on till I reach my sample size of 300 houses. So my last house number will be 1500. So which is 300 into 5. Alright. In this way you can keep the interval as 3. You can keep the interval as a geometric mean, arithmetic mean. But it needs to be periodic. Just keep that in mind. If we follow this, this is called as a systematic random sampling. These are the 4 methods that we've discussed. Now we will move on to the non-probability sampling method. As the name suggests, it's not random at all. Non-probability sampling method is done when the population is unknown. You don't have a finite sampling frame with you. You don't usually know what is your sampling frame here. So what do? You choose the sample according to your own convenience. The researcher does that. It is allowed. And this is usually done in exploratory studies where you are not completely aware what your population is, what you're trying to find out. You are basically exploring those ideas. We'll be discussing 4 types of non-probability sampling, starting with convenience sampling. What is convenience sampling? In this type of sampling, the participants are selected based on their availability or first come first serve methods. Maximum biasness of the researcher comes into mind here because usually this type of sampling is not considered a very good technique. Because see, if a population is there and you are reaching it at your own convenience, you might miss out those people who are actually there in the maximum part of the population. But since there was a person who was in front of you, you chose that person and that becomes a part of your sample. The easiest example when comes into mind is when we float our Google Forms. So we float it at our own convenience. Whoever is filling those forms, it is at our own convenience. We don't randomly select people and actually float out those forms to those randomly selected people. So this is what is called convenience sampling. Now, the second example of non-probability sampling or second method is called the quota sampling. As you can see, quota sampling is very much simpler to stratified sampling because here we again divide them into different subgroups, and each subgroup is different from another. But internally they are same. So as the name suggests, there is certain quota or subgroups that are divided from the population. An example is, let us just divide the population according to the education background. So we divided that according to the education background, and the first quota is belonging to all those who studied till class 12th or below. Second is all the graduates and the postgraduates and doctorates and higher. And this is how we've divided it. And then we make samples in each quota. And after we've selected those samples at our own convenience, we calculate the total sample size, and that is the total sample that you need for your study. So this is called as a quota sampling. The third type of non-probability sampling is the judgment or the purposive sampling. As the name suggests here, this sampling method depends on the judgment of the researcher when choosing the sample. So if the researcher feels that they should include someone who's there in their sample, who should be there in their sample, the researcher does that. An example of this type of sampling is, let's say your study is based on social activists working on tree plantation drives. So you want to know what do they believe in, how is their behavior. You want to just explore that, and that has not been explored yet. So what do? You choose those people who are working in that particular sector, but you choose them according to your judgment. If you feel that that person is really inclined, you will choose that person because you really want to know the belief. Some of them might not be working for their own will to work in that sector, but just for their work. But that entirely depends on your judgment. So that is why this is called as a judgment sampling. Okay, now we move on to the last type of non-probability sampling that we'll be doing in this course is called as a snowball sampling. Snowball, as you know, just imagine that there is a small snowball, and as it keeps on rolling down the hill, it increases in its size. So similarly, in snowball sampling, you as a researcher know a very small or a limited population. And this is usually done when you're doing niche areas of studying. So an example of this is maybe you're doing a study on the physical fitness of all the women who have disabilities and are using prosthetic limbs in India. So maybe you don't know all those women who are using prosthetic limbs and you want to know more about them. There is no particular listing of these women in India. What do? You contact a physiotherapist or a doctor who might be knowing. So you contact them. They'll be giving a reference to you that these are 3, 4, maybe 5 people I know, 5 women who are using prosthetic limbs. You approach those women, and if they are willing to talk to you about their physical fitness, they will. And maybe those 4 women will give you a reference of more women. And this is how your sampling is increasing. And your sample number increases till a point that you reach your data saturation. Data saturation is when you start getting similar answers, similar responses. So that is the point where your data is saturated, and that is exactly the point where you stop your sampling in snowball sampling. So this is where we end with different types of sampling methods. And let me just quickly tell you the difference that is there between probability and non-probability sampling. As we've already discussed earlier, probability sampling is used when we have the information about the entire population or we have the sampling frame with us. In non-probability sampling, we do not have the sampling frame, and it is usually done where we are doing an exploratory study or a qualitative study. Probability sampling, we randomly select the sample, whereas non-probability, we do not select the sample randomly. That is done at our own convenience. Probability sampling is considered to be more reliable, and the results can be easily generalized to the population since they are randomly chosen. But in non-probability, since it is done at your own convenience, the sample, as I had mentioned earlier as well, may not be reliable, and they may not entirely represent the population that you've chosen for your study. Probability sampling is expensive, of course, and it's time consuming as well as compared to non-probability sampling, where it is done at your own convenience. So it saves time and it saves money. Probability sampling is less prone to sampling errors and the biasness in the results. Whereas non-probability sampling, there are a lot of biasness in your results because it is done at your own convenience, and they are more prone to sampling errors. So that is it for today's session. We'll be continuing more on module 3 in the next session. I hope you learned something new in this session, and I look forward to continue this in the next session. Thank you so much.